Now let's look at some slightly more complicated examples. For example, this particular problem, f of x equals 5 times x squared times e to the 3x, is actually a product rule. And we can think of the 5x squared as one factor and the e to the 3x as the other factor. It's a product of those two factors. Now recall that the product rule tells us how to do that. If it's been a while since you've used it, let me just help you recall it. If you have the product of two factors and you want to take the derivative, the product rule tells you to take the first factor, multiply it by the derivative of the second factor, then take the second factor, multiply it by the derivative of the first factor, and then add those two products together. That's the product rule, and you've seen that before, just reminding you. So let's move things out of the way and let's use the product rule to compute this derivative. If I'm thinking of the 5x squared as a single factor and the e to the 3x as a single factor, then the 5x squared becomes like the u and the e to the 3x becomes like the v in the product rule. Therefore, according to the product rule, the derivative of this product will simply be the u, which is the 5x squared, multiplied by the derivative, and I'll just write it out in symbols the first time, the derivative of the second factor, which is e to the 3x, that's the v, plus, then I take the second factor, which is v, in this case e to the 3x, and I multiply that by the derivative of 5x squared. And on the first step, I'll just write that in symbols. I want to take the derivative of 5x squared. Now, obviously, as you get better at this, you can skip some of these steps that I'm writing out. But for the time being, I'm going to do that. So here we have 5x squared times. Now, the derivative of an exponential takes us back to this formula. According to this, the derivative of an exponential is the exponential multiplied by the derivative of the exponent. The g prime of x is the derivative of g of x. So according to that, the derivative of e to the 3x is e to the 3x, but then it's multiplied by the derivative of 3x, but the derivative of 3x is 3. Okay, continuing. Now we have in the second term e to the 3x multiplied by the derivative of 5x squared, which of course is simply 10x. So if we clean that up a little, we can take the 5 and the 3 and multiply together and get 15. And then we have the x squared and the e to the 3x. Then we have the plus, and normally we would write the 10x first, so it would be 10x e to the 3x. At this point, you probably notice that there's a common factor. There's a 5 inside of that 10 and also inside that 15. There's an x in this factor as well as inside of there, and there's an e to the 3x in both. So we can actually factor out a 5 and an x and an e to the 3x. So the least common factor is 5x times e to the 3x. Now that leaves us a 3 from the 15 because 5 times 3 is 15. We took an x from an x squared, leaving us with x, and the e to the 3x came out. Then the second term, we take a 5 from a 10, leaving 2, because 2 times 5 is 10. We took the x, and we took the 3x. So that's about as simple as you would ever want to write it. So we've taken the derivative of the original product where one of the factors is itself an exponential. And you can see it now a little bit cleaned up. I'm just listing every step there without all of my marks and circlings done. But the bottom line is the derivative is as I said, 5x e to the 3x times the quantity, or times the factor, 3x plus 2. Let's look at another. Suppose now we want to find the derivative of a quotient. We want to find the derivative of f of x equals e to the negative x plus 1, that entire quantity over e to the x. That obviously is a quotient rule. So that means that you have to remember what the quotient rule says. And in case you don't, I'll put it here. The derivative of a quotient, I wrote n and d to make you think of numerator and denominator. The derivative of the numerator, the derivative of a fraction with a numerator and denominator, according to the quotient rule, is the denominator multiplied by the derivative of the numerator minus the numerator times the derivative of the denominator, that entire quantity over the square of the denominator. That's the quotient rule, and you remember it from working earlier. I'm just simply reminding you of it here. Now let's move things up and out of the way so we can actually do this problem. I want to use the quotient rule to define the derivative, to find the derivative. So I began f prime of x, according to the quotient rule, it's going to be a fraction, so I'll go ahead and put in the fraction bar. It's the denominator, which is e to the x. Remember, we're just reading off the rule here. It's the denominator, which is the e to the x, multiplied by the derivative of the numerator. Well, the numerator is e to the minus x plus 1, and I'm going to just write it out symbolically for now. It's the derivative of the numerator. Okay, now continue with the formula. We have minus, and now we take the numerator, which is e to the minus x plus 1, and multiply that by the derivative of the denominator, and I will write it out symbolically on the first step. So the derivative of the denominator, and the denominator is e to the x, so it's just the derivative of e to the x. And then according to the quotient rule, the whole thing is divided by the square of the denominator. So that would be the denominator, which is e to the x, quantity squared. Looks a little messy, but we'll simplify it. We first have to go in and take those derivatives. So the very first thing I'll do here is say f prime of x is equal to e to the x times the derivative of e to the minus x. Remember, we're going back now to the derivative formula for the exponential. The derivative of e to the minus x is e to the minus x times the derivative of minus x. But the derivative of minus x is minus 1. Continuing, we have this minus sign here, minus. Now we've got e to the minus x, e to the minus x plus 1 quantity multiplied by the derivative of e to the x. But the derivative of e to the x is e to the x times the derivative of x, which happens to be 1. And then looking at the denominator, when you have a power raised to a power, you multiply. So e to the x quantity squared is e to the 2 times x. When you raise a power to a power, you multiply the exponents. Okay, now things will fall out fairly quickly. If I take this minus sign and multiply it through, I just get a negative term. So that would become negative e to the x, e to the minus x. And then in the second term, to the right of the minus sign, I've got just an e to the x sitting here, so I can just drop the 1. So I end up with e to the minus x plus 1 times e to the x. And that entire thing now is divided by e to the 2x. Well, I guess the next thing I would do is multiply out the parentheses on the right. If I do that, I end up with f prime of x is, and well, actually, I'll go ahead and simplify the first one too. Remember, when you have a power, when you multiply with like basis, you add the exponents. So you really end up with a negative e to the x plus minus x. But x plus minus x is 0, so you end up with e to the 0. And then multiplying out the parentheses, you have to be really careful here because that minus sign is going to distribute. You get e to the minus x times e to the x, e to the minus x times e to the x, and then, well, that's what you get when you multiply here. And then when you multiply the e to the x times 1, you simply get e to the x. And that entire thing is over e to the 2x. Let's continue over here. As we all know, e to the 0 is 1. Any non-zero number to the 0 power is 1, so that first term in the numerator just becomes minus 1. Minus, I still have my parentheses, e to the minus x times e to the x. Again, when you have like bases, you add the exponents, and if you add a minus x and an x together, you end up with 0. So you, again, as before, you have another e to the 0 popping up here, and then plus e to the x. It's just a lot of arithmetic and algebra here at this point. You've done all the calculus. Continuing, you get minus 1 minus, now e to the 0, as we discussed earlier, is 1, so you get 1 plus e to the x, excuse me, e to the x. Let's do a better job on that. All over e to the 2x. Now I can distribute and get rid of the minus sign. So I get f prime of x is minus 1, and then distribute the minus across there as well, and I get minus e to the x all over e to the 2x. Well, minus 1 times minus 1 is minus 2, and really that's about all you can do with it, so you end up with f prime of x. In fact, I'll take an extra step up here. Minus 2 minus e to the x all over e to the 2x. And that's fine if you leave the answer like that. The only thing else you might do is you might write the exponential first, so you could also write it minus e to the x minus 2 all over e to the 2x. So if you write it like that, that's fine. If you left it in that form, that would also be fine. So now we've worked a problem with a product rule and a quotient rule where one of the factors or one part of the quotient had an exponential in it. Let's do one more. First of all, I'm going to clear out my all my handwriting and all my distractions and let you see the problem worked out step by step. So you can see this is exactly what I did earlier. I just got rid of all my marks and circles and underlines. Now let's do one more. This is also a quotient rule. The function is f of x equals 100 over the quantity 2 plus 9 times e to the 0.3x. It's still a quotient rule. So obviously we'll need the quotient rule again. And to make a little room, I'll shove everything up. and apply the quotient rule. It's the same process as before. There's nothing inherently different about it, at least in principle. The quotient rule is a quotient, so I'll write a fraction bar in there. And the quotient rule says you take the denominator, which would be 2 plus 9e to the 0.3x, and you multiply it by the derivative of the numerator. So you've got the derivative of the numerator, which is 100. Okay, continuing. Minus, now you reverse it, take the numerator, multiply it by the derivative of the denominator. So you've got 100 times the derivative of the quantity 2 plus 9 e to the 0.3x, all over the square of the denominator. So that's 2 plus 9 e to the 0.3x, that whole quantity squared. Continuing, we have 2 plus 9 e to the 0.3x. Now the derivative of 100 is 0. The derivative of any constant is 0. Minus 100 times the derivative of this sum. So I've got to take the derivative of the 2, and then I have to take the derivative of the exponential. Well, again, the derivative of a constant is 0, so the derivative of 2 is 0, plus 9 e to the 0.3x. We've done one like this earlier. If you've got a constant times an exponential, it's just going to be the constant multiplied by the derivative of the exponential. The derivative of an exponential is the exponential written just as it is, but multiplied by the derivative of the exponent. So we've got to take the derivative of 0.3x, but the derivative of 0.3x is just 0.3. And of course we still have the denominator, so I'll simply copy it back down. Now it's pretty much a matter of just cleaning things up and simplifying them. When I multiply anything by 0, I just get 0, so that whole thing just goes to 0. But I have minus. Now the 100 has to multiply by the 0, but that's still 0, and it has to multiply by the second term. I left out a parenthesis here, let me put it back in. It might be easier if I just went ahead and dropped the 0 and took an extra step. I don't want to do too much in one step, and that's probably a lesson to be learned. I'm just going to drop the 0 in this step and write down the second term, but I will put the 9 and the 0.3 next to each other because they'll eventually get multiplied together. And I'll copy down the denominator. Now notice what I did in the numerator. This product just became 0. I just eliminated this 0 right here. I just completely dropped that out. And I took the 9 and the 0.3 and put them next to each other. That's all I did. So as I did before, I can just drop the 0 minus part. That's just going to be 0. I just get rid of that. So all that's really left to do is multiply. Don't forget the minus sign. Actually, I probably need to write that a little differently. The minus sign doesn't go away. It's just the 0 part that goes away. I don't want to make it look as if I'm taking off the minus sign. So I've just got to put a negative and then multiply those three numbers together. You can do it on your calculator, but I know that 9 times 0.3 is 2.7, and 2.7 times 100 is 270. Do it on your calculator if you like, but you end up with a negative because of this negative sign. You still have a negative sign, and then those three numbers together, multiplied together, come out to be 270, and then you have then e to the 0.3x. And this entire numerator then is divided by 2 plus 9 e to the 0.3x quantity squared. And that's really about as simple as you can write it. So here I've applied the quotient rule again, where one of the terms had an exponential in it. And as I've done in the past, I'll clear out my underlines and highlightings and just let you see the work a little more clearly.